details. Around 70 teams participated globally in the Code for India Hackathon that happened simultaneously at the Google headquarters in the US and in the Tech Mahindra office in Noida. Two of Prime Minister Modi's pet projects, Digital India and Skill India, were the themes for this hackathon. For a period of 15 hours, coders and web developers came together to build a product keeping in mind the theme. 4 winners were announced in the US and 10 were announced in Noida. The team we have today is called Farmer Next, and they finished off in the top 3 positions in India. Let's go to Ashray Malhotra first. I believe that we're still trying to connect to him. Ashray, can you hear me?
Yeah, I can.
Okay, he is a final year student at IIT Powai. Thanks very much for joining us. I'd like to ask you, what was the challenge you picked and why did you pick it up?
Okay, so the challenge that we had picked up was to identify farm activities and to identify soil properties.
And why did you pick it up? Why that?
So I stay in Mumbai and I hear a lot about farmer suicides in Marathwada and other places in Mumbai, especially this year because of the drought. Most people around here keep beating around the bush and pushing the responsibility to solve this problem to others. But we decided that let's just try and give a decent attempt to try to solve this problem and do something ourselves.
So what did you do? Explain to us, how would that help the farmers?
Yeah. So what we have come up is both a hardware and a software part. We have a device which we can plant in the soil. It can read many characteristics of the soil, so once we have a lot of these units put up in the farms, all of this data goes to a central cloud to the internet, where scientists and researchers can process this data. And after processing, a very simple SMS or an Android app notification is sent to the farmer, which can tell him on how he should behave next, on how should he plant which seeds, or should he give more water next time, or which fertilizer to use and stuff like that.
Excellent. I couldn't even imagine that can be done as a part of a hackathon. Perhaps we're all different generations. So what does it mean for you, Ashray, now that you are one of those winners?
Yeah, so we are happy that we've been able to make something, and we hope that people take it forward. So everything that we've built has been open sourced. We have publicly released the entire source code. We've even released the hardware information that we've built. So this was a genuine effort from our part to build something and to start something big. We hope that people like it and people take it forward to the next generation.
Ashray, thanks very much for joining us. With that, many congratulations. We're moving on to Kamla now. Kamla Sripada is with 3 other students who've also won. Kamla, over to you.
All right, Anchal, we just heard Ashray Malhotra explain to us the kind of hardware that they had built, essentially the device that they had built. I have with me somebody who's going to explain to us how this particular device works. Abhishek, thank you so much for speaking. So tell us, once we put this device in soil, what happens next?
The device sends the moisture, humidity, temperature and some more data of the soil to the web server, and we receive those data and we analyze them and we compare those data to the optimum data that is required for the fertilization of crop, for the better fertilization of crop. So we compare the soil and the most optimum data, and we notify the farmers on their app that you should practice these things to make the soil better. You should put these fertilizers, or you should make the soil more moisture.
All right, so you're talking about how you're going to send an update to an app.
Yeah.
But if there's a farmer who doesn't have access to an Android app,
yeah.
Then how would they receive this message? Will they be able to access this device that you've made?
Yeah, we discussed about this thing that most of the farmers must not be having internet connection and they might not have the Android phone. So we had implemented SMS API so that they will receive updates through the SMS that they need to add some fertilizers or water the soil for the better cultivation of crops.
All right, so you've used, there's a hardware component to this as well as a software component to this. Is this a very expensive device to make? Take us through how much it costed you to make this.
Okay, no, it's not much costly. It's around, we can build it in 550 to 600 rupees only. The main cost is of the hardware component which we will be putting on the farms that will be sending the data. That is the only cost, and it will be around 500 to 600 rupees.
All right, thank you so much for speaking with us, Abhishek. So Anshul, you just heard it from the members of this team saying that this is a device, a software that's going to reach out to farmers in India, and it's not very expensive to make. Their estimated cost is not more than 600 rupees, Anshul.
Kamala, thanks very much for joining us with those details. If the 600 rupee device can bring a change to the lives of our farmers, how wonderful would that be? With that, we're slipping into a break. I'm back with more in just a bit.